Hello everyone. In this video we will see how to solve the plane truss problem by making use of Ansys software. So this is the problem, that is plane truss. Okay, now for this I will first open the Ansys mechanical APDL, and first I'll set the preferences to structural. The preference is to structural, and then I'll go to preprocessor and I'll choose the element type. I'll add the element which is the link element in here. Yes, a link element I'll add, and then I'll simply close it. Then after this I'll add the material properties of the material which is given, that is steel, and the material properties basically here are Young's modulus and Poisson's ratio, and here I will be doing millimeter modeling, that is the Young's modulus will be in terms of Newton per mm square. Okay, so I entered the values of Young's modulus and Poisson's ratio for steel now. Fine. Then I will enter the cross-sectional area of the truss by making use of real constant option, and the cross-sectional area is 100 mm square. I'll enter that and I'll click OK and close it. Then I'll move forward to modeling this, wherein I'll create the nodes in active CS, and here basically I'm going to create 3 nodes. First node at 0, 0, 0, second node at 400, 300, and third node at 0, 300. So now the 3 nodes have been created, and we can see the 3 nodes in different views, different possible views. Okay, now I will create the elements through those 3 nodes. These elements will be auto numbered, and I'll use the option through nodes. I'll create one element between these 2 nodes. I'll press apply, and then I'll create one more element between these 2 nodes, and again I'll click on OK. So now you can see there are 2 elements which are created through 3 nodes. Okay, and yeah, that will be visible. Yeah, this is the elements that we have created. Now there is no need to mesh here because directly we have created nodes and elements. Now I'll simply apply the boundary conditions, and first let me apply the constraints, and I'll choose the option and apply boundary conditions at the nodes, that is these 2 nodes. I'll apply ux, uy, uz because they can't move in x, y and z direction, and then I'll apply force on this another node. How much is that force? That force is in y direction, and it is acting downwards, and hence it is negative 10 kilonewton. So this is the loading condition, and now I can directly go on solving this problem. I'll simply click solve and currently ls. So I'll click OK. The solution will be done. Yes, the solution is done. Now I'll have to go to general postprocessor in order to extract the result, and for that to happen, let me create the element table to extract the stress and strain values. This ls corresponds to stress values, lep corresponds to strain values. Now I'll go to list results, and I'll go to element table data, where I will extract ls1 and lep1 to extract the results. Now ls1 values are the stress values, whereas lep values are the strain values. As simple as that. And then I'll have to find out the support reaction, and the support reaction is at node 1 and node 3 in this direction here. And ultimately I have to view the contour plot to view the complete deformation of the truss. So I'll go to DOF solution, I'll select displacement vector sum, I'll click on OK, and the total deflection will be 1.08 mm, and that will be the maximum deflection. Thank you.